The smoke curled upward from Elijah Sutherland's fireplace on a February morning in 1841, rising through 8 square ports cut into a massive wooden beam, wrapping around 24 strips of venison hanging in the darkness above. Across the valley, Levi Wardlow stood in the smoking ruins of his separate smokehouse, watching a winter's worth of preserved meat turn to ash. Before we begin, drop a comment letting us know where you're watching from, and if stories of forgotten frontier ingenuity speak to you, hit that subscribe button, because tomorrow's tale is even more remarkable than this one. The snow measured 4 feet deep on the level ground by January of 1839. In the drifts between the pine trees northeast of the Yellowstone River tributaries, it reached 8 feet or more. Elijah Sutherland had seen hard winters during his 6 years trapping beaver in the Montana Territory, but this season carried a weight that went beyond cold or snow depth. This winter felt like the mountains themselves were testing every man who dared remain. Elijah returned to his camp on the 15th of January after checking his northern trap lines. He had been gone 3 days, working his way along a frozen creek, where beaver sign remained promising despite the brutal cold. His pack horse carried 7 pelts, good thick winter fur that would bring premium prices come spring. He was thinking about those prices, calculating his potential profit, when he saw his smokehouse. The structure had collapsed under the snow load sometime during the previous night. The roof timbers lay splintered across the frozen ground. The walls, never particularly sturdy to begin with, had folded inward, and scattered in the wreckage, partially buried in snow and completely exposed to scavengers, lay his entire winter meat supply. Elijah stood motionless for a full minute, processing what he was seeing. 3 elk, 2 deer, and countless strips of beaver tail and bear meat, all smoked and preserved over the autumn months, now destroyed. He could see where ravens had already found the exposed meat. Tracks in the snow showed that a fox had investigated during the morning hours. Within days, larger scavengers would finish what remained. His partner Rufus Tyndall emerged from the main cabin, pulling his bearskin coat tight against the cold. He surveyed the collapsed smokehouse and shook his head. "Bad luck," he said. "Just bad luck. These things happened in the mountains. They would make do with what remained in the cabin stores, hunt fresh game when weather permitted, and rebuild the smokehouse come spring." Elijah did not respond immediately. He was calculating. They had perhaps 6 weeks of meat remaining in the cabin. The winter would likely last another 12 weeks, possibly 14. If spring came late, as it often did in this territory, fresh game was scarce during deep winter. Deer and elk moved to lower elevations. Even rabbits became difficult to find when snow accumulated this deep. Rufus seemed unconcerned. He had survived lean times before. Most mountain men had. You tightened your belt, stretched your provisions, maybe visited a neighboring camp to trade for supplies. It was part of the life they had chosen. But Elijah was thinking about something else entirely. He was thinking about separation. His smokehouse stood 30 yards from his cabin, 30 yards that required venturing out into whatever weather the mountains offered, 30 yards that made the preserved meat vulnerable to collapse, to fire, to animal intrusion, to any number of failures that could occur when structures stood isolated and unattended. That night, while Rufus slept, Elijah lay awake watching smoke from their fireplace rise toward the cabin ceiling, pool in the peak of the roof, then drift toward the chimney opening and disappear into the winter darkness outside. Rufus Tyndall died on February 9th, 1839. The circumstances were mundane in the way that mountain deaths often were. No bear attack, no fall from a cliff, no dramatic confrontation with hostile raiders, just a simple miscalculation about weather and distance. The morning had started clear and relatively warm, temperature hovering near 20 degrees. Rufus decided to check his smokehouse, located 40 yards from the cabin he shared with 2 other trappers in a camp 5 miles from Elijah's location. His meat supply was running low, and he wanted to retrieve several strips of elk to supplement their dwindling stores. The weather changed within an hour. Wind came down from the northwest, bringing temperatures that dropped 30 degrees in less than 2 hours. Snow followed, thick and blinding. Rufus never made it back to his cabin. They found him 2 days later when the storm cleared. He was 18 yards from his smokehouse, frozen solid, one hand still clutching the bundle of meat he had retrieved. He had become disoriented in the whiteout conditions, walked in the wrong direction, and collapsed before realizing his error. Elijah helped bury Rufus on a hillside above the creek when the ground thawed enough to dig. 4 trappers attended. No one spoke much about how it happened. Everyone understood. The mountains killed men in countless ways, and freezing to death between your smokehouse and your cabin was as likely as any other method. But Elijah could not stop thinking about the distance. 40 yards for Rufus, 30 yards for his own ruined smokehouse. These were not vast distances. A man could walk 40 yards in less than a minute under normal conditions. But winter in the Montana Territory created conditions that made 40 yards as dangerous as 40 miles. He started paying attention to other trappers' camps over the following weeks. Every camp had the same basic layout. Main cabin for living and sleeping. Separate smokehouse positioned at least 20 yards away, usually farther. The separation was traditional, rooted in practical concerns about fire risk and smoke management. No one wanted a smokehouse fire spreading to their living quarters. No one wanted their cabin constantly filled with smoke. The logic seemed sound until you factored in winter reality. Maintaining a smokehouse fire required daily attention. Temperature had to stay consistent for proper preservation. That meant venturing out multiple times each day, regardless of weather. It meant exposing yourself to cold, wind, and disorientation every single time you needed to check your meat supply. Elijah began sketching designs in the margins of an old ledger book he used for tracking trap lines. His drawings showed cabins with modified roofs, internal chambers, chimney systems that branched in unusual ways. None of the designs satisfied him. They were too complicated, too difficult to build, or they compromised either the living space or the smoking process. Then, one evening in late February, he was watching smoke rise from his fireplace, and something clicked in his mind. The smoke did not go straight up. It rose toward the ceiling, spread out, pooled in the warmth, and only then moved toward the chimney opening. That pooling represented wasted heat and wasted smoke. Both elements could preserve meat if channeled properly. What if the smoke did not need to be separated from the living space? What if integration was the answer instead of separation? Elijah stopped trapping in early March. Spring was approaching, beaver pelts were losing their prime winter thickness, and he had enough furs to make the journey to St. Louis worthwhile. But instead of working his remaining trap lines, he spent his days studying his cabin's fireplace and chimney system. He burned different types of wood and observed how the smoke behaved. Hardwoods like oak and hickory produced steady, cool smoke that lingered longer before rising. Softwoods like pine created hotter, faster-moving smoke that rushed toward the chimney. He experimented with fire size, noting that smaller fires generated smoke that spread more evenly through the upper cabin space before exiting. His few neighboring trappers thought grief over Rufus had affected his mind. Amos Critchfield stopped by in mid-March and found Elijah sitting motionless, watching smoke patterns near his ceiling. Amos asked if he was feeling well. Elijah explained he was studying heat distribution. Amos left shaking his head, but Elijah was learning principles that most men never considered. Heat rose, everyone knew that, but heat did not rise instantly. It took time for warm air to accumulate and push toward the highest point in a structure. During that accumulation period, the heat radiated outward, warming everything it contacted. The longer you could keep heat in a space before it escaped, the more efficient your heating became. Smoke behaved similarly. It rose because it was hot and less dense than cold air, but it could be slowed, controlled, channeled. If you created barriers that forced smoke to travel horizontally before rising vertically, you increased the time it spent in the space. More time meant more heat transfer and more opportunity for the smoke to contact anything positioned in its path. Elijah started measuring his cabin's dimensions with careful precision. He measured the height from floor to ceiling peak. He measured the width of his fireplace opening. He calculated the volume of his living space and estimated how much smoke his typical fire produced per hour. He was applying mathematical thinking to a problem that most mountain men solved through tradition and guesswork. By late March, he had filled 6 pages of his ledger with sketches and calculations. The design taking shape in his mind was radical. He would build a massive beam directly above his fireplace opening, positioned to catch all rising smoke. The beam would be solid except for carefully sized openings that would control smoke flow. Above the beam, he would create space for hanging meat. The smoke would be forced through the openings, would pass around the hanging meat, and would then continue to the chimney. The beam itself would serve multiple purposes. It would act as a thermal mass, absorbing heat and radiating it back into the cabin. It would create a platform for the meat hanging system. It would control smoke velocity and distribution, and it would separate the active smoking area from the living space while keeping everything under one roof. The design seemed perfect in theory, but Elijah had no idea if it would actually work. The only way to find out was to build it. Elijah left for St. Louis on April 2, 1839. He carried 47 beaver pelts, 3 bear hides, and 2 elk hides, packed on 2 horses. The journey would take 3 weeks if weather cooperated. Most trappers made this trip annually, sold their furs, bought supplies, spent a few days drinking and gambling, then returned to the mountains. Elijah had different plans. He had money saved from previous seasons, nearly $300 in gold and silver coins hidden in his saddlebags. That represented 4 years of careful living and disciplined saving. Most trappers spent their profits as fast as they earned them. Elijah had been preparing for something, though until recently he had not known exactly what. The journey east was uneventful. Spring was arriving in the lower elevations. Rivers ran high with snowmelt but remained crossable. Game was plentiful. Elijah made good time, arriving in St. Louis on April 23rd. He sold his furs the following day to a buyer he had worked with before. The pelts brought $212, a solid return for the season's work. Then Elijah did something unusual. Instead of heading to the taverns along the riverfront, he spent his days studying buildings. He visited a warehouse district south of the main commercial area and watched construction crews working on a new storage facility. He paid particular attention to how they built roof support beams, how they calculated load distribution, how they joined heavy timbers together. He visited a commercial bakery and studied their brick ovens. The ovens were massive structures designed to hold heat for hours after the fire died down. The bakers explained thermal mass principles, how certain materials absorbed and released heat slowly, creating stable temperatures perfect for bread making. Elijah took mental notes about brick thickness, mortar composition, and chimney draft control. He found a meat packing facility on the western edge of town and talked his way into observing their smoking operations. They used enormous smokehouses, 50 feet long and 20 feet tall, with complex vent systems that controlled smoke density and temperature. The facility manager explained that slow, cool smoking produced superior preservation compared to hot, fast smoking. Temperature control was everything. Elijah spent nearly 2 weeks in St. Louis learning everything he could about heat management, smoke control, and structural engineering. He filled another ledger book with sketches and notes. Then he spent his money. He bought 6 heavy iron brackets designed for barn construction. He bought 24 iron pins, each 2 feet long and 3/4 of an inch thick. He bought specialized tools including a broad axe, a froe for splitting shingles, and a plumb bob for ensuring vertical accuracy. When he left St. Louis on May 8th, his pack horses carried an unusual load for a mountain man. No whiskey, no tobacco, no playing cards, just tools, hardware, and knowledge. Other trappers heading west looked at his supplies with confusion. Amos Critchfield, who happened to be in St. Louis at the same time, asked outright what he planned to build. "A better cabin," Elijah said. Amos laughed and said, "Any fool could build a cabin in 4 days." Elijah did not argue. He had learned that explaining vision to skeptics was pointless. Results would speak louder than words. Elijah returned to the Montana Territory on June 1, 1839. He selected a new cabin site 3 miles from his previous location, choosing high ground with clear sight lines and good drainage. The spot was less convenient for water access, requiring a longer walk to the creek, but it offered strategic advantages that mattered more than convenience. He spent the first week felling trees. Most trappers used whatever timber grew nearby, but Elijah was selective. He wanted straight-grained pine for the main logs, hardwood for structural beams, and cedar for anything that would contact smoke regularly. He marked trees, studied their grain patterns before cutting, and rejected any timber with significant defects. Amos Critchfield rode through on June 12th and found Elijah still selecting and cutting timber. Most men would have started building by now. Amos asked what was taking so long. Elijah explained he was being particular about wood quality. Amos shook his head and said, "Particular was just another word for slow." The foundation went in first, something most mountain cabins lacked entirely. Elijah dug a shallow trench around the cabin perimeter and filled it with stones from the creek, creating a level base that would prevent settling. The work took 3 days. Amos stopped by again and watched Elijah placing stones with almost ridiculous precision. "You building a cabin or a church?" Amos asked. Elijah said he was building something that would last. Amos laughed and said nothing lasted in the mountains. Weather, animals, and time destroyed everything eventually. Might as well build quick and rebuild when necessary. But Elijah continued with his methodical approach. The wall logs went up slowly, each one carefully fitted to minimize gaps. He stripped the bark completely, something most trappers never bothered with. Bark created irregular surfaces and harbored insects. Stripped logs could be fitted together with minimal chinking. The real divergence from standard construction came when Elijah began building his fireplace. He constructed it in the corner of the cabin, using stones he had selected specifically for their flat surfaces and consistent size. The firebox was larger than typical, designed to accommodate longer logs that would burn slowly and steadily. But above the firebox, instead of building a simple chimney, Elijah installed the massive beam he had shaped from a single oak log. The beam measured 14 inches thick, 20 inches tall, and spanned the entire width of the fireplace opening, plus 2 feet on either side. It was anchored into the wall logs using the iron pins he had brought from St. Louis, creating a rigid connection that would support substantial weight. Amos arrived with 2 other trappers, Bennett Shaw and Thomas Kern, on June 28th. They stood outside watching Elijah struggle to position the heavy beam. Thomas asked what in God's name he was building. Elijah explained it was a smoke shelf that would allow him to cure meat inside his cabin while heating the space simultaneously. The 3 men stared at him in silence. Then Amos said it was the stupidest waste of timber he had ever seen. A fireplace was for heat. A smokehouse was for meat. Combining them made no sense. You would either freeze or ruin your meat, or both. Elijah did not argue. He simply continued working, positioning the beam with careful precision, checking its level, adjusting until everything aligned perfectly. The beam installation took 4 days. Elijah worked alone, using ropes and leverage to position the massive oak timber exactly where he wanted it. The beam sat 18 inches above the fireplace opening, close enough to capture all rising smoke, but far enough to prevent direct flame contact. Once positioned, he drilled holes through the beam into the supporting wall logs, then drove iron pins through to create permanent connections. Each pin went through the beam and at least 8 inches into solid wood. The result was a structure that could not shift or settle. The beam became part of the cabin's framework. With the beam secured, Elijah began the most critical part of his design. He marked 8 locations along the beam's length, spacing them evenly at intervals of approximately 9 inches. At each mark, he began cutting square openings through the beam from bottom to top. The openings measured 3 inches by 3 inches, sized based on calculations he had made during his sleepless nights the previous winter. Too large, and smoke would rush through without adequate contact with meat hanging above. Too small, and smoke would back up into the living space, making the cabin uninhabitable. Cutting the openings was painstaking work. The beam was oak, dense and hard, resistant to tools. Elijah used an auger to drill multiple holes at each location, then cleaned out the remaining wood with chisels. Each opening took half a day to complete. He worked with obsessive precision, ensuring each port was perfectly square and aligned vertically. By July 15th, all 8 ports were complete. Elijah built a small fire in the fireplace to test smoke flow. The smoke rose from the flames, hit the underside of the beam, spread horizontally along the beam's length, then began rising through the ports. The flow was exactly what he had envisioned. Smoke distributed across all 8 openings, rising in gentle streams rather than one powerful draft. He let the fire burn for 3 hours, monitoring smoke behavior. The smoke rose through the ports as designed, but more importantly, the beam itself began warming. Oak had excellent thermal mass properties. It absorbed heat slowly but held it for extended periods. Even after the fire died down, the beam continued radiating warmth into the cabin space. The beam was working as a dual-purpose element. It channeled smoke upward through controlled openings, while simultaneously acting as a radiator that captured and released heat. Above the beam, he began constructing the meat-hanging system. He installed cross-beams between the cabin's roof supports, creating a framework that would hold substantial weight. From these cross-beams, he hung hardwood dowels at 6-inch intervals. Each dowel could support multiple meat strips. The positioning was critical. Meat needed to hang where smoke would pass after rising through the beam ports, but before exiting through the chimney. Elijah tested different heights using wet fabric strips, observing where smoke concentrated. By late July, the integrated system was structurally complete. Elijah spent August refining details that most trappers would consider unnecessary. He built a damper system in the chimney that allowed him to control draft intensity. By adjusting a simple iron plate suspended on a chain, he could increase or decrease the rate at which smoke exited the cabin. More draft pulled smoke through faster. Less draft allowed smoke to linger longer around the hanging meat. He constructed shelves along one wall for storing supplies, positioning them high enough that rising heat would keep everything dry but low enough for easy access. He built a sleeping platform at the opposite end of the cabin from the fireplace, elevated 2 feet off the ground. The elevation would keep him in a temperature zone that was warm but not hot, as heat stratified vertically in the enclosed space. The door received exceptional attention. Elijah built it from thick planks with tongue and groove joinery, then reinforced it with iron brackets. The door was designed to seal tightly, preventing cold air infiltration that would disrupt his carefully planned temperature control. He installed leather weather stripping around the frame, creating an almost airtight seal when closed. Windows presented a challenge. He needed ventilation for temperature control and light for working inside, but windows compromised thermal efficiency. His solution was to build small windows positioned high on the walls, where they would not create drafts across the living space. He fitted them with shutters that could be opened for ventilation or closed for maximum heat retention. The fireplace itself received modifications throughout August. Elijah lined the firebox with fire bricks he had made himself using creek clay and sand. The bricks reflected heat forward into the room rather than allowing it to be absorbed by the stone structure. He shaped the firebox with angled sides that directed heat outward, a technique he had observed in the St. Louis bakery ovens. He built a stone apron in front of the fireplace, extending 4 feet into the room. This served multiple purposes. It protected the wooden floor from sparks and embers. It provided workspace for fire management. And most importantly, it acted as additional thermal mass that absorbed heat during the day and released it slowly through the night. By September 1st, the cabin was complete except for chinking between logs. Elijah had prepared a special mixture for this final step. Most trappers used mud and moss, materials that were free and readily available but prone to cracking. Elijah mixed clay from the creek with cut grass and pine resin. He had collected and boiled down from sap. The mixture was labor-intensive to prepare, but resulted in chinking compound that was waterproof, flexible, and adhesive. He packed it between logs while still warm and pliable, pressing it deep into gaps and smoothing the exterior surface. The chinking work took 2 weeks. Elijah filled every gap methodically, ensuring no air could penetrate the walls. On September 18, 1839, Elijah moved his supplies into the completed cabin and lit his first sustained fire in the new fireplace. The system performed exactly as designed. Smoke rose through the beam ports, heat radiated from the oak beam, and the interior temperature stabilized at a comfortable level despite cold evening temperatures outside. Elijah spent the final weeks of summer testing his system with small fires and careful observations. He was not simply experimenting randomly. He was applying principles he had learned in St. Louis, combined with his own observations about smoke behavior. The key was understanding that smoke and heat were related, but behaved differently under controlled conditions. Heat rose quickly and sought the highest point in any enclosed space. Smoke, being heated, air carrying particulate matter, followed similar patterns but could be slowed and directed if obstacles were placed in its path. The massive oak beam served as that obstacle. When smoke hit the underside of the beam, it spread horizontally before finding the vertical ports cut through the timber. This horizontal spreading was critical. In a standard fireplace, smoke rose in a concentrated column directly up the chimney. The speed of that rise meant minimal heat transfer to the surrounding space. Most of the thermal energy went straight outside, but by forcing smoke to spread horizontally along the beam before rising, Elijah increased the time smoke spent inside the cabin, which meant more heat transfer. The 8 ports served multiple functions beyond simply allowing smoke passage. Their size and spacing controlled velocity. Smoke rising through 8 small openings moved slower than smoke rushing through one large chimney. Slower movement meant more time for heat radiation and more thorough contact with anything hanging in the smoke path. Elijah also discovered that the beam's thermal mass created a buffering effect. When he built a hot fire, the beam absorbed excess heat and released it gradually. When the fire burned low, the beam continued radiating stored warmth. This meant the temperature in the meat curing zone above the beam remained relatively stable regardless of fire intensity below. He documented everything in his ledger: fire size, wood type, outside temperature, inside temperature at floor level, inside temperature at the beam level, inside temperature in the meat hanging zone, smoke color, smoke density, and duration of warmth after fires died down. The data showed consistent patterns that supported his design theory. Hardwoods produced the best results. Oak, hickory, and maple burned slowly and generated steady smoke with good flavor for meat curing. Pine and other softwoods burned too hot and fast, creating temperature spikes that could cook meat rather than cure it. Cedar produced excellent smoke for preservation, but was harder to find in sufficient quantities. Fire size mattered more than Elijah had initially anticipated. Small fires maintained with regular feeding produced better results than large fires allowed to burn down. Small fires generated consistent smoke volume and stable temperatures. Large fires created heat surges that the beam's thermal mass could only partially buffer. The damper system proved essential for fine control. By adjusting how quickly smoke exited through the chimney, Elijah could regulate how long smoke lingered in the meat-hanging zone. On cold days, he reduced the damper opening to retain more heat. On warmer days, he opened it wider to prevent overheating the curing meat. By late September, Elijah felt confident he understood his system well enough to begin actual meat preservation. He had spent 3 months building and another month testing. Most trappers would have considered this absurdly excessive for a simple cabin. But Elijah was not building a simple cabin. He was engineering a survival system that would keep him alive through winter without requiring him to venture outside to tend a separate smokehouse. October brought the first serious cold and the beginning of hunting season. Elijah took a large mule deer on October 8th, field dressed it, and packed the meat back to his cabin. This would be the first test of his integrated smoking system with actual meat, rather than theoretical calculations and fabric test strips. He butchered the deer carefully, cutting the meat into strips approximately 1 inch thick, 6 inches wide, and 12 to 18 inches long. Uniform thickness was important for even curing. He prepared a simple brine using salt, water, and a small amount of maple sugar, then soaked the meat strips for 12 hours. The brining process was standard frontier practice. Salt drew moisture out of the meat while inhibiting bacterial growth. The sugar balanced the salt's harshness and would caramelize slightly during smoking, adding flavor. After 12 hours, Elijah removed the strips from the brine and hung them on the dowels above his smoke shelf beam to drain. He built his fire using seasoned hickory wood he had split and stored during the summer. The fire was small, no larger than what he would build for simple cabin heating. Within an hour, smoke was rising steadily through the 8 ports in the beam, surrounding the hanging meat strips in a gentle fog. Elijah monitored temperature carefully. At floor level, the cabin was comfortable, around 60 degrees. At the beam level, temperature was perhaps 70 degrees due to heat radiating from the oak. In the meat-hanging zone 2 feet above the beam, temperature held steady around 85 to 90 degrees. This was ideal, hot enough to discourage bacteria, but cool enough to prevent cooking. The smoke itself was thin and blue-gray, the color that indicated clean burning with minimal creosote. Thick white smoke would have meant incomplete combustion and would have given the meat an acrid taste. Black smoke would have indicated too much heat. The thin blue smoke was perfect. He maintained the fire for 18 hours, feeding it small pieces of hickory every 2 hours. The rhythm became meditative. Feed the fire, check the meat, adjust the damper slightly, observe smoke patterns, record observations in his ledger. By evening of the first day, the meat strips had developed a dark surface and had shrunk noticeably as moisture left them. The second day followed the same pattern. Small fire, steady smoke, consistent temperature. The cabin remained comfortably warm, despite outside temperatures dropping to near freezing at night. Elijah realized he was heating his living space and preserving his winter meat supplies with the same wood consumption he would have needed just for heating alone. On the third day, he noticed the meat had formed a pellicle, a slightly tacky surface layer that indicated proper drying. The strips were firm to the touch, but not brittle. He continued smoking for 2 more days, then let the fire die down and allowed the meat to hang for another day in the residual smoke and warmth. On October 14th, 6 days after hanging the venison, Elijah took down the first strip and examined it carefully. The meat was dark brown, almost mahogany-colored. It was firm and dry, but not desiccated. He cut a thin slice and tasted it. The flavor was excellent, smoky, slightly sweet from the maple sugar with the clean taste of properly cured venison. Most importantly, it showed no signs of spoilage. Amos Critchfield arrived on October 20th with 2 other trappers, Bennett Shaw and a new man named Gordon Petrie, who had just arrived in the territory. They were making rounds to neighboring camps before winter isolation set in, sharing news and checking on supplies. When they entered Elijah's cabin, they stopped and stared. 24 strips of smoked meat hung from the framework above the fireplace beam. The cabin was warm and comfortable. A small fire burned in the fireplace, and thin smoke rose through the ports in the beam, surrounding the hanging meat before disappearing up the chimney. The entire space smelled of wood smoke and cured venison. Amos walked slowly around the cabin interior, examining the smoke shelf beam, the hanging meat, the careful construction details. He touched one of the meat strips, feeling its texture. He looked up at the ports cut through the beam. Then he started laughing. "You spent 4 months building this contraption," he said. 4 months of careful measuring and precise cutting and worrying about smoke flow. And for what? To do something that any trapper does in 4 days with a separate smokehouse. Gordon Petrie agreed. The setup seemed unnecessarily complicated. Why go to such effort to combine 2 functions that worked fine when separated? The risk seemed obvious. If something went wrong with the fireplace, you lost both your heat and your meat preservation. If the cabin caught fire, you lost everything instead of just one structure. Bennett Shaw was more measured in his criticism, but still skeptical. He acknowledged the cabin was well built and the meat looked properly cured, but he questioned whether the time investment was justified. A man could build a standard cabin and a separate smokehouse in the time Elijah had spent on this single integrated structure. Elijah did not defend his choices. He simply explained how the system worked. The beam captured heat and channeled smoke. The ports controlled smoke velocity and distribution. The thermal mass stabilized temperature. One fire served 2 purposes: cutting wood consumption in half while eliminating the need to venture outside during winter storms. Amos shook his head. It was ingenious, he admitted, but also impractical. The construction required skills and tools most trappers did not have. The iron hardware was expensive. The time investment was ridiculous. And most fundamentally, it solved a problem that was not really a problem. Yes, maintaining a separate smokehouse required going outside. But that was just part of mountain life. You accepted it. The 3 visitors left an hour later. As they rode away, Elijah could hear them talking and laughing. He caught fragments of their conversation. Sutherland's folly. Waste of effort, too clever by half. He returned to his cabin, added wood to his fire, and continued curing the elk meat he had hung that morning. Their opinions did not matter. Winter would provide the real test. November came early and hard in 1839. The first major storm hit on November 6th, dropping 2 feet of snow in 36 hours. Temperatures plunged to 15 below zero. Wind howled down from the high peaks, creating drifts that buried anything less than 4 feet tall. Elijah spent 3 days inside his cabin while the storm raged. He maintained his fire, kept his meat smoking, and remained comfortable. The cabin's tight construction prevented drafts. The smoke shelf beam radiated steady warmth. The temperature at floor level never dropped below 55 degrees despite the brutal cold outside. He had 40 strips of meat hanging at various stages of curing. Some had been smoking for 2 weeks and were nearly finished. Others had just been hung and would need another 10 days. The system allowed him to cure meat continuously rather than in batches. As he finished one batch and took it down, he could hang fresh meat in the same space. On the 4th day, the storm broke. Elijah ventured outside to check conditions and gather more firewood from his covered woodpile. The snow was waist-deep in places. Traveling any distance would be difficult and dangerous. He thought about Rufus, frozen 18 yards from his smokehouse, and felt grateful for his integrated system. He spent the rest of November perfecting his techniques. He experimented with different wood combinations, finding that mixing hickory with small amounts of applewood produced the best flavor. He tested various brining times, discovering that thicker meat strips needed longer in the salt solution. He learned to read smoke color and adjust his fire accordingly. By late November, he had over 60 pounds of smoked meat stored in his cabin. The meat hung in the curing zone until fully preserved, then he moved it to shelves where it would keep for months. He also began smoking fish when he could catch them through holes in the creek ice. The fish required less smoking time than venison or elk, but benefited from the same controlled temperature and smoke density. December brought more storms. Elijah rarely left his cabin for more than an hour at a time. He checked his trap lines when weather permitted, but spent most days inside, tending his fire and managing his meat preservation. The routine was simple and efficient. Small fire, steady smoke, comfortable warmth, continuous food preparation. Other trappers in the area were making daily trips to their smokehouses regardless of weather. Amos visited briefly on December 18th and mentioned he had fallen through creek ice the previous week while heading to check his meat. He had gotten wet in 20 below temperatures and nearly froze before making it back to his cabin. He looked at Elijah's setup with less mockery than before, but still seemed unconvinced the effort was worthwhile. Christmas passed unmarked except for Elijah, allowing himself an extra portion of smoked venison. He was alone, but not lonely. The cabin felt secure. His food supply was growing rather than diminishing. His firewood supply was lasting longer than expected because he was not maintaining two separate fires. Everything was working according to plan. January would bring the real test. January was when mountain winters became truly dangerous, when temperatures stayed below zero for weeks, when storms could trap a man inside for 10 days straight. Elijah had prepared for January since the previous February, when Rufus had frozen. Now he would discover if his preparation was sufficient. The winter of 1839 to 1840 became one of the coldest in recorded frontier memory. January temperatures dropped to 30 below zero and stayed there for 2 weeks. Snow accumulated to depths that made travel impossible. Even short trips to gather firewood became dangerous expeditions requiring careful planning. Elijah maintained his routine with almost mechanical precision. Every morning he cleaned the previous day's ashes from his fireplace, preserving them for later soap making. He rebuilt his fire using the coal bed that remained, adding small pieces of seasoned hardwood in a careful arrangement that promoted clean burning. The fire size never varied much. Too large, and he wasted wood while creating temperature spikes that could damage meat. Too small, and smoke production dropped below optimal levels. He had learned through 2 months of practice exactly how much wood produced the right amount of smoke and heat. 3 pieces of split hickory, each about 2 inches thick and 12 inches long, burned for approximately 2 hours while generating perfect smoking conditions. He fed his fire 12 times per day, every 2 hours from 6 in the morning until midnight. The schedule was demanding, but necessary. Consistent fire maintenance meant consistent smoke production and stable temperatures. His meat cured evenly without developing spoilage or off flavors. Temperature monitoring became instinctive. He no longer needed to check with his hand at different heights. He could feel the thermal stratification in the cabin and knew immediately if something was wrong. Floor level should feel cool, but not cold. The smoke shelf beam should radiate gentle warmth. The meat hanging zone should feel warm, but not hot. The damper required adjustment based on outside conditions. On extremely cold days, he closed it partially to retain more heat inside the cabin. On slightly warmer days, he opened it more to prevent overheating the meat. Wind direction also mattered. Strong northwest winds created better draft, so he compensated by closing the damper slightly. His meat production exceeded his consumption by a comfortable margin. He was eating approximately 1 pound per day, but he was curing closer to 2 pounds per day when he had fresh game to process. The surplus accumulated on his storage shelves, insurance against future shortages or unsuccessful hunting. He also discovered his system worked for other preservation methods. He could dry herbs in the warm zone near the beam without exposing them to direct smoke. He could cure fish faster than traditional methods because the controlled temperature prevented freezing, while the smoke inhibited bacterial growth. The cabin itself performed better than expected. The tight construction meant heat loss was minimal. Elijah was burning perhaps one-third the wood he would have needed to heat a standard cabin to the same temperature. When he factored in the elimination of a separate smokehouse fire, his total wood consumption was less than half what other trappers required. By late January, he had developed a deep understanding of his system's capabilities and limitations. He knew which woods produced which flavors. He knew how outside temperature affected inside conditions. He knew how to adjust for humidity, wind, and barometric pressure changes. The integrated smoke shelf had evolved from theoretical design to practical tool. February 18, 1840, brought a storm that would be remembered for decades. The temperature dropped to 42 below zero, the coldest reading anyone in the territory had ever recorded. Wind screamed down from the mountains at speeds that knocked down trees. Snow fell so thick that visibility dropped to less than 5 feet. Elijah heard the storm coming hours before it arrived. The wind shifted to the northeast, always a bad sign. He spent the afternoon gathering extra firewood and stacking it inside his cabin. By sunset, he had enough wood inside to last 5 days without venturing out. The storm hit at midnight. Wind struck the cabin with physical force, rattling the shutters and seeking any weakness in the construction. Snow piled against the north wall, creating drifts that reached the roof line. The temperature inside dropped despite Elijah's fire, falling from its normal 60 degrees down to 45 by morning. He increased his fire size slightly, adding an extra piece of wood to each feeding. The smoke shelf beam's thermal mass became critically important during this period. Even when outside temperatures reached their lowest point, the beam held enough heat to prevent the cabin from becoming dangerously cold. The meat hanging above continued curing properly. The storm lasted 4 days. Elijah remained inside the entire time, leaving only once to dig out his door when snow blocked it completely. He could not see his woodpile 30 feet from the cabin. Venturing out for any distance would have been suicidal. Other trappers were not as fortunate. Levi Wardlow's smokehouse, a separate structure 40 yards from his main cabin, required daily attention to maintain proper smoking temperatures. On February 20th, Levi made the trip from his cabin to his smokehouse to add wood to the smoking fire. The wind disoriented him on the return trip. He wandered in the wrong direction, realized his error, tried to correct, and became completely lost in the whiteout conditions. He survived only because he literally stumbled into a deadfall tree that provided minimal shelter from the wind. He huddled there for 6 hours until the storm intensity decreased enough for him to see landmarks. By the time he reached his cabin, he had severe frostbite on both hands and 1 foot. He would lose 3 fingers and 2 toes. But the immediate crisis for Levi was not his injuries. During the hours he spent lost in the storm, his smokehouse fire had died. The temperature inside dropped below freezing. When he finally checked it 2 days later, he discovered his entire winter meat supply had frozen, then partially thawed when temperatures moderated, then frozen again. The freeze-thaw cycle had ruined the meat. What had not spoiled was so damaged by ice crystals that it was barely edible. News of Levi's disaster spread through the scattered trapping community as weather improved. Several trappers visited Levi in early March to check on his condition and offer assistance. Amos Critchfield was among them. After seeing Levi's injuries and ruined meat supply, Amos rode to Elijah's cabin. He arrived on March 7th. Elijah invited him inside. The cabin was warm and comfortable. Fresh venison strips hung above the smoke shelf, curing in steady smoke from a small fire. Dozens of completed meat strips lined the storage shelves. Amos stood silently for several minutes, looking at the system he had mocked 5 months earlier. Then he asked if Elijah would explain exactly how he had built it. Amos Critchfield sat at Elijah's table and listened with an attention he had never shown before. He asked about beam dimensions, port sizing, spacing between hanging dowels, and thermal mass principles. He took notes in a small book he carried, drawing rough sketches as Elijah explained the construction process. The mockery was gone from Amos's voice. He had seen what happened when systems failed during extreme conditions. Levi Wardlow was alive but crippled, his trapping career finished at age 32. His meat supply was destroyed. He would survive the remainder of winter only because other trappers shared their provisions. The cost of traditional smokehouse separation had become undeniably clear. Elijah walked Amos through every aspect of his design: the foundation that prevented settling, the careful log selection and fitting, the iron pins that anchored the smoke shelf beam into the wall structure, the precise dimensions of the ports cut through the beam, the positioning of the meat-hanging framework in the optimal smoke and temperature zone. He explained the thermal mass concept in simple terms. The oak beam weighed approximately 400 pounds. Oak held heat exceptionally well. When smoke and heat rose from the fire and contacted the beam, the wood absorbed that thermal energy. The beam then radiated heat back into the cabin space over extended periods. This created stable temperatures even when the fire burned low or outside conditions became extreme. The ports controlled smoke velocity and distribution. 8 small openings moved smoke slower than one large chimney. Slower smoke meant more time in contact with hanging meat. More contact time meant better curing. The even distribution across 8 ports prevented hot spots that could cook meat instead of preserving it. Amos asked about wood consumption. Elijah showed him his wood pile and explained he was using roughly half the wood other trappers needed. One fire heated the cabin and cured meat simultaneously. No separate smokehouse fire meant significant savings. Over a full winter, the difference was substantial. Elijah estimated he saved at least 2 cords of wood compared to traditional setups. The damper system allowed fine control of smoke flow and heat retention. Amos examined the simple iron plate suspended on a chain in the chimney. By raising or lowering the plate, Elijah could adjust how quickly smoke exited. More draft on calm days, less draft on windy days, or during extreme cold. The adjustment was simple, but critical for maintaining optimal conditions. Amos asked the question that mattered most: could this system be built by someone with average carpentry skills? Elijah was honest. The construction required more time and skill than standard cabins. The beam installation was difficult without help. The port cutting was tedious and required precision, but none of it was beyond the capability of a reasonably competent builder willing to invest the effort. The iron hardware was expensive, but not prohibitively so. The specialized tools helped, but were not absolutely necessary. A man could build a similar system using wooden pins instead of iron, though the connections would not be as strong. The key was understanding the principles rather than copying exact specifications. Amos left 3 hours after arriving. He said he would think about what he had seen. Elijah suspected that meant Amos would build his own version come summer. Over the next 2 weeks, 4 more trappers visited. Word had spread about Levi's accident and Elijah's successful winter. Spring arrived in early April 1840. Snow melted rapidly under warm sun and steady rain. Creeks ran high with runoff. The mountains transformed from white and gray to green and brown almost overnight. Trappers emerged from winter isolation to assess survival, share news, and prepare for the summer building season. Hosea Brandt visited Elijah on April 19th. Hosea was older than most mountain men, 47 years old, with 2 decades of frontier experience. He had survived through competence and careful planning rather than luck or toughness. He was known for studying problems before acting and for adopting better methods when he encountered them. Hosea examined Elijah's cabin with the eye of an experienced builder. He studied the smoke shelf beam closely, running his hands along the underside where smoke had deposited a dark patina. He counted the ports and measured their dimensions with a folding rule he carried. He climbed up to examine the meat-hanging framework and noted how the dowels were positioned and spaced. He asked technical questions that showed he understood the underlying principles. How much weight could the beam support? What happened if a port became blocked? How did smoke behavior change with different wood types? What was the minimum fire size that still produced adequate smoke? Could the system work in a smaller cabin, or did it require specific dimensions? Elijah answered each question thoroughly. The beam could support at least 300 pounds above its own weight. Blocked ports were prevented by keeping the chimney clean and using properly seasoned wood. Different woods produced different smoke characteristics, with hardwoods being superior for meat curing. Minimum fire size depended on outside temperature and desired smoke density, but was generally quite small. The system could scale to different cabin sizes, but port dimensions and spacing would need adjustment. Hosea spent the entire day at Elijah's cabin, taking detailed notes and making careful measurements. Before he left, he asked if Elijah would be willing to advise him during construction of a similar system. Elijah agreed. He had no interest in keeping the design secret. If the system helped other men survive mountain winters more safely, that was benefit enough. Hosea returned to his own camp and spent 2 weeks planning. He had an existing cabin that he considered rebuilding entirely, but after consulting with Elijah again, he decided modification was possible. The existing fireplace could be enlarged, and a smoke shelf beam could be installed above it. The work would be substantial, but less than complete reconstruction. He began construction in mid-May. Elijah visited twice during the building process to offer guidance on critical steps. The beam installation was challenging without help, so Elijah assisted with positioning and securing the heavy timber. The port cutting went slowly because Hosea was methodical and wanted each opening perfectly sized and aligned. By late June, Hosea's modified cabin was functional. The smoke shelf beam was in place with 8 ports cut through. The meat-hanging framework was installed. The chimney had a damper system copied from Elijah's design. Hosea built his first fire and watched smoke rise through the ports exactly as intended. He spent July testing and adjusting. He discovered that his cabin's different dimensions required slightly different damper settings than Elijah used. His ports were marginally larger, which meant faster smoke flow that he had to compensate for. But the fundamental system worked as designed. One fire heated his cabin and provided smoke for meat curing. By August, Hosea was curing venison successfully. The winter of 1840 to 1841 was milder than the previous year, but still harsh by any standard. Multiple storms dropped heavy snow. Temperatures regularly fell below zero. Several trappers lost smokehouses to structural failure under snow loads. 2 men suffered frostbite injuries while tending separate smoking fires during blizzard conditions. Hosea Brandt survived the winter comfortably in his modified cabin. His integrated smoke shelf system performed as well as Elijah's original design. He cured over 200 pounds of meat without ever venturing more than 20 feet from his door during the worst storms. His wood consumption was noticeably lower than previous winters. In spring of 1841, 5 more trappers began building cabins with integrated smoke shelf systems. None copied Elijah's design exactly. Each man made modifications based on available materials, personal preferences, and specific site conditions. But all incorporated the core principles: a massive beam above the fireplace with controlled ports, thermal mass for heat retention, and meat-hanging framework positioned in the smoke path. Thomas Kern built a variation using 2 smaller beams instead of 1 massive timber. The dual-beam design was easier to install without help but provided less thermal mass. Bennett Shaw experimented with port placement, staggering them in 2 rows instead of 1 line. A trapper named Silas Harmon built an elaborate version with adjustable ports that could be opened or closed individually using wooden plugs. Amos Critchfield, who had been among the first to mock Elijah's construction, built his version in summer of 1841. His cabin incorporated several improvements he had observed from other builders. He used a combination of oak and hickory for the beam, claiming the mixed wood provided better heat retention. His meat-hanging system included adjustable hooks that could be raised or lowered to optimize smoke exposure. By autumn of 1841, 12 trappers in the Montana Territory were using some variation of the integrated smoke shelf design. The systems had acquired a name in casual conversation. Men called them Sutherland beams, after Elijah, who had built the first one. Elijah neither encouraged nor discouraged the name. He was simply pleased that other men were surviving winters more safely. The adoption was entirely organic. No one promoted the design formally. No written instructions circulated. Trappers who wanted to build the system visited someone who already had one, studied the construction, asked questions, and then built their own version adapted to their circumstances. Knowledge spread through observation and conversation rather than documentation. Not everyone adopted the innovation. Some trappers remained committed to traditional methods. Separate smokehouses had worked for decades and would continue working if properly maintained. The integrated system required construction skills and time investment that not every man possessed or was willing to provide. Some men genuinely preferred the separation of functions, even acknowledging the convenience of integration. But for those who built integrated smoke shelf systems, the advantages were undeniable. Safer winter operations, lower wood consumption, continuous meat curing capability, stable interior temperatures, the elimination of dangerous trips to separate structures during storms. These benefits were practical and measurable, and they saved lives that would otherwise have been lost to the simple act of walking 40 yards through a blizzard to check on smoking meat. By 1845, the Rocky Mountain fur trade was collapsing. Beaver populations had been trapped to near extinction in many watersheds. European fashion had shifted away from beaver felt hats toward silk, destroying the market that had sustained mountain men for 2 decades. Trappers began leaving the mountains, heading to Oregon, California, or back to eastern settlements. But the cabins remained. Structures built with integrated smoke shelf systems stood abandoned across the Montana and Wyoming territories. These were not typical frontier cabins that deteriorated rapidly once unmaintained. The careful construction, solid foundations, and quality materials meant many would stand for decades. Settlers moving west in the late 1840s discovered these abandoned cabins. They found structures with unusual wooden beams above fireplaces, beams with square ports cut through them. Most settlers initially had no idea what purpose these beams served. Some thought they were structural supports. Others assumed they were failed experiments or eccentric design choices. Then someone would light a fire and watch smoke rise through the ports. They would notice how the beam radiated heat long after the fire died down. They would see the meat-hanging framework above and realize the entire system was designed for dual purposes. The innovation became obvious once observed in operation. Settlers began occupying and maintaining these cabins rather than building new structures. A well-built cabin with an integrated smoke shelf system was superior to anything most homesteaders could construct themselves. The time saved in construction allowed families to focus on clearing land, planting crops, and establishing farms. Word spread through settler communities about cabins with special fireplace systems that heated living spaces while preserving meat. Families sought out these structures specifically. A cabin with a Sutherland beam, as they were still called, was considered a valuable find. Some settlers even modified their own newly built cabins after seeing the integrated system in abandoned trapper structures. The technique spread beyond its original territory. Settlers who had experienced the system in Montana built similar designs when they moved to Oregon or Northern California. Miners in the Colorado Gold Rush of 1859 adopted variations for their mountain camps. Army posts on the frontier sometimes incorporated the principles into their more permanent structures. The designs continued evolving. Some builders added metal grates in the ports to prevent ember passage. Others experimented with different beam materials or alternative port configurations. A few innovative builders created systems with 2 tiers of meat-hanging racks, effectively doubling preservation capacity. The core concept remained consistent, but details varied based on local conditions and builder preferences. By 1860, integrated smoke shelf systems had become common enough in frontier territories that they no longer seemed unusual. New settlers arriving from the east saw them as standard frontier construction rather than innovative design. The systems had transitioned from experimental to traditional within 2 decades. Records from the period are incomplete, but references to smoke shelf cabins appear in numerous settler diaries, military reports, and territorial surveys. The prevalence suggests hundreds of structures incorporated some version of the design across the mountain territories. Most builders probably never knew the system originated with a trapper named Elijah Sutherland, who had lost his partner to winter and decided there had to be a better way to survive. Elijah Sutherland left the Montana Territory in spring of 1844. He was 33 years old and had spent 8 years trapping beaver in the mountains. The fur trade that had drawn him west was finished. He sold his cabin to a younger trapper named Daniel Wolf for $75, a fair price that included the structure, tools, and trap lines. He took his savings and headed to Oregon Territory, where land was available under favorable terms for settlers willing to work it. He filed a claim for 160 acres in the Willamette Valley south of Salem. The land had good soil, adequate water, and timber for building. Elijah married in 1846. Her name was Martha Brennan, daughter of another Oregon settler who had arrived 2 years earlier. They had 4 children over the next decade. Elijah built a farmhouse, cleared fields, planted wheat and vegetables, and raised cattle. He was a competent farmer who applied the same careful planning to agriculture that he had once applied to cabin construction. He rarely spoke about his trapping years. Mountain life was behind him. He had survived it, learned from it, and moved on. His children knew their father had been a trapper before settling in Oregon, but they knew few details. The smoke shelf cabin, the innovative system that had spread across multiple territories, was never mentioned in family conversations. Elijah died on March 12, 1867, at age 56. Pneumonia, common enough in men who had spent years in harsh conditions. He was buried in a small cemetery outside Salem. His gravestone listed his name, birth, and death dates, and identified him as a farmer. No mention of trapping, no reference to innovations, or surviving brutal winters in the Montana mountains. His widow Martha lived another 23 years. Their children grew to adulthood, married, started their own families. None ever learned about the cabin their father had built in 1839, the system that had saved lives, or the quiet legacy that had spread across the frontier. But in the mountains, the cabin stood. Some were still occupied in 1867 when Elijah died. Others had been abandoned again as settlement patterns shifted. A few had been destroyed by fire or catastrophic weather. But many remained, solid structures with massive beams and square ports, still functioning exactly as designed 3 decades earlier. Settlers living in these cabins during the 1860s and 70s had no idea who had invented the integrated smoke shelf system. It was just how certain mountain cabins were built. The name Sutherland Beam persisted in some areas but meant nothing to people who had never met Elijah or known his story. The legacy was completely anonymous. Elijah had shared his innovation freely, never seeking credit or profit. He had helped other trappers build their own versions without requiring recognition. The result was a technique that saved lives and improved frontier survival, but remained unattributed to any individual inventor. In that anonymity lay a peculiar kind of success. The innovation had become so integrated into frontier building practice that its origins no longer mattered. It simply worked, and that was enough.